Ladies and gentlemen, Aheri Stanford-Asiyo. She's a software engineer at Microsoft. She's ex-senior JavaScript engineer of Accenture, where she's active in the Liquid Studio in Silicon Valley. And she's the ex-chief, which is really cool, the ex-chief of Mission Control Security at the National Reconnaissance Office, responsible for sensitive global satellite operations. So combine that with her knowledge, 2D, 3D, the technology, the HoloLens, and having that background in these satellites, either you're working with James Bond or you're an Avenger, something like that. It's got to be something like this. So great background. You're currently working on next-gen holographic computing solutions for the workplace with an app called Microsoft Dynamics 365 Guides, which the audience, of course, will know. And it's just basically, as I understand it, because you know me, I don't have a tech background, so you're going to say a lot of stuff that I don't understand. Holographic experience in training environments so people can use the HoloLens and train better. Now, in short, you call that rethinking, it's a whole mouthful. You call that rethinking accessibility from 2D to 3D. So I would say, glad you're here. I know it's midnight somewhere. You're probably tired. You're ready to go to sleep, but you look pumped. So I'm really happy to have you. The virtual floor is yours. Have fun.
Thank you so much. What a wonderful, warm welcome. I'm going to share my screen so that we can get popping. There may be some screen inception going on at first, and here we are in 2020, the world of technology. Beautiful, so I think we're all set. And I'm getting a different screen than you all are, isn't it?
We're currently seeing you.
All right, here's how we're going to do it. I'm going to share a little bit differently.
Right. Now something
there we
happened.
go. Beautiful.
There you go.
Okay. Good morning. And Dos Verano, it is midnight here in Vancouver, Canada. But I seem to be on the other side of the planet as far as sunshine. Thank you for that awesome introduction. My name is Aheri Stanford-Asiyo, and I work as a software engineer for Microsoft here in normally sunny but often also rainy Vancouver, British Columbia, in Canada. I want to thank OpenSlava for welcoming me. And I also want to give a great shout out to the organizers of the conference. Being an Accenture alum has made me feel quite close to this conference, so it's sort of a nice moment to come back. So in 2018, I joined Microsoft's Mixed Reality at Work team. And that was in order to build what we're now calling Dynamics 365 Guides. It is a mixed reality application, which is a training platform for the HoloLens, which I show a photo of myself wearing. Let's see if that actually will happen. And the photos, and we are advancing. We're advancing. It's happening. Beautiful. Prior to that, I was a senior JavaScript engineer at the Accenture Liquid Studio, hence the liquid to your left. And that was in Silicon Valley, where we were introducing emerging technologies to typically Fortune 500 businesses. You all know the game. It's a beautiful game. And I'm really delighted to return and participate in this conference, which itself is a brainchild of a highly influential mentor of mine, Pavel Tsaran. I was inspired to enter the engineering world after an 8-year-long career as a civil servant at the US CIA, where I also served in a rotational role at the National Reconnaissance Office, where I was essentially protecting a pretty dazzling array of technical innovations as they were developed and deployed for operational uses. But I really longed, even within that intelligence environment, to work in a world where the opportunities for emerging technologies and emerging tech could be leveraged for empowering more people and increasing their quality of life, perhaps even where emerging tech and open source could meet, like they do at OpenSlava. So what in the world is Dynamics 365 Guides, really? Well, essentially, Guides is a mixed reality tool that allows employees to learn by doing, using interactive instructions. It lets operators of these guides learn during the flow of work by providing them holographic instructions when and where they need them in context. But as usual, a picture can speak 1,000 words.
Modern businesses need to constantly innovate, recalibrate, and optimize to stay competitive. Dynamics 365 Guides uses mixed reality to help workers adapt to complex scenarios in daily operations, from training to assembly to service and repair. Step-by-step instructions are easily written on PC, and then holographic parts and icons are simply picked up and placed on the machine where the work happens. Novice and experienced employees can both learn and adapt quickly while doing their tasks. The instructions move with the employees, pointing them to the tools and parts they need, showing them exactly where they need to apply them. And with easy-to-author branching, managers can account for all the variables and changing conditions of their operation, allowing employees to get up to speed faster, follow the right procedures with fewer errors, and more confidence. Managers can also leverage Guides insights to combine the data generated from doing the work with transactional data, driving optimizations and continuous improvement faster than ever before. All of this is connected to the cloud, so instructions are always up to date, allowing your employees and your business to adapt at the speed of change.
Since I've been working at Microsoft, I've learned that more than 1 billion people, or 15% of the global population, live with a disability. And that number is expected to double before 2050. Because of that, I have become, within the last 2 years, my team's technical accessibility champion. And so as part of my engineering work, each day, I bring that perspective with me to work. During the planning, the development, the building of the 2 components of the Guides application. Sorry about that. Let's advance to the next slide. The one that sits in the 3D environment for PC, I'm sorry, the one that sits in the 2D environment for PC. So let's recontextualize here. There are truly 2 parts of the Dynamics 365 application, the Guides application. The one that sits in a 2D environment for PC and that lets our users easily create a structure for their guides, to add steps, to add images, to add videos, and finally to add 3D holograms. And the second, which for our users sits in the 3D world on HoloLens and allows them to place those 3D parts in space as guide authors. And finally, there's a handoff that takes place, still in the 3D world, to an operator of the guide. As an accessibility champion, the first part, the one for 2-dimensional devices and screens, that job is relatively simple. basic accessibility standards and practices are pretty well defined in the 2D world. The World Wide Web Consortium, or the 3WC, provides standards for accessibility that are internationally recognized by governments and by businesses. The most well-known of them is the WCAG, or the Web Content Accessibility Guidelines, which is also known as ISO 40500, and was also adopted into the European standard, EN 301-549. Although those standards arose for and were inspired by the internet, the strategies apply to mobile and desktop environments and 2D surfaces all in between. The 3WC also provides guidelines that are specifically for code editors, for media players, for content management systems, and for other software. So what do those 2D standards truly tell us? Well, they tell us that our applications need to be perceivable. They need to provide captions like the ones that you're seeing right now, or other alternatives when we add multimedia. They need to provide text alternatives for non-text content. They need to give the user control over the speed of that media. They need to present content in different ways. They also need to be operable. All functionality needs to be available from a keyboard. They need to provide users enough time to read and use content that's presented, and provide ways to help users to navigate, find, and determine the location of their own location in the UI to determine where they are. They also need to be understandable to make text readable, and they need to help users avoid common mistakes and correct them. They need to ensure that content appears in a predictable way. And finally, our applications in 2D have to be robust, meaning they need to maximize compatibility so that the content can be readable by a wide variety of tools, including assistive technologies. Typically, the very bones of our user interface, the front-end code, is used to address those things. The markup code, typically the HTML, the CSS, your front end. So it's translated. Your HTML, for instance, is translated into objects in what's called the UIA tree, the User Interface Automation Tree. An automation tree that provides assistive technologies, the ability to give a user a tailored experience. So accessibility in 2D is typically implemented through manipulating the markup code. For HTML, ARIA attributes. For XAML, automation properties. We also know that semantic markup is more accessible for the experiences of these users. In fact, it was exactly this kind of semantic approach that influenced the current syntax of HTML. These days, when we're creating HTML code, we use navs, headers, and footers, rather than divs or spans. In fact, in 2014, this became the official W3C recommendation, because using semantic elements like nav, header, footer, and audio or video to replace the general element object actually notified all assistive technologies exactly what to expect. So the influence of the accessibility ecosystem on the markup language that we use today is often taken for granted. So let's look at some examples of 2D accessibility in Guides PC. But wait. first, I want to clear up a very common misconception. When we're talking about accessibility, we can't see all users who require assistive technologies as a monolith. About 10% of people with a visual disability have lost all ability to see. In the pie chart that I show above, that 10% is represented by an orange slice. And these users have lost 100% of their vision. But now look at the remaining pie, which is in blue. It represents the other 90% of individuals with visual impairments. These individuals still, to some extent, perceive light and shape. And the same goes for any motor, sensory, or cognitive disability. When we talk about disabilities, it's important to recognize that individuals have experiences on a wide spectrum. You might have noticed my selection of an orange slice to represent that 10%. And this brings us to a topic that 8% of men experience, and a total of about 200 million people worldwide, which is colorblindness, a form of visual impairment. I used an orange slice and a blue pie because for users who would see, as we would on the left here, red, orange, yellow, green, blue, and purple, the shades orange and blue will consistently look very different from one another. Here we are at a key principle of web accessibility. Users with colorblindness need to be able to perceive the difference between certain color combinations. Let's get back to it and see an example of 2D accessibility in the Guides PC application. So here, a user is on a page where they have the ability to choose between 3 different choices. The implications of selecting each choice is indicated using an icon or a small dash. And as you might expect, a seeing user who lands on this page of our application might check each of the column row intersections to make some conclusions about the implications of their selection. To do this, they're perceiving shape, they're perceiving color, and they're perceiving positions of icons in this case. But what about a user who has a different experience? Let's take a moment and see how such a user would use an assistive technology, in this case, a narrator screen reader, to see the information at these intersections and make a choice.
Dynamics 365 Guides window, Anchor selection page. Learn more. QR code has high accuracy, custom. QR code supports variable marker size. QR code is a HoloLens 2 feature. QR code requires a printer. Select QR code button. Person scanning a printed circular code anchor using HoloLens 1. Circular code. Link, learn more about circular code. Learn more. Circular code has medium accuracy. Circular code supports a single marker size. Circular code is compatible with all HoloLens devices. Circular code requires a printer. Select circular code button. Person manually aligning a holographic anchor using HoloLens 2. Holographic. Link, learn more about holographic anchor. Learn more. Holographic anchor has low accuracy. Marker size does not apply to holographic anchor. Holographic anchor is compatible with all HoloLens devices. Holographic anchor does not require a printer. Select holographic anchor button.
So using HTML, markup code, and in this case, XAML, we simply can set a property to the text which should be spoken for the logic that a seeing user would conclude from these images and icons. And when we set those properties, they appear in the user interface automation tree. So any assistive tool can transmit it to the user the way that the user needs it. In addition to having some pretty well-defined standards for the 2D world, we also have the ability to choose some tools to verify whether or not our work meets the target accessibility standards that we want it to. We can use tools like the Website Accessibility Checker, the Accessibility Insights tool. This one scans HTML content for compliance and basically produces a report on known problems, likely problems, potential problems, and even links to how to address them. The list goes on in terms of just how many tools are available in the open source world to validate things like your contrast between the text and its background, your selection of colors, your tabbing order. These checkers work by climbing up and down the UIA tree, just like the screen reader that we just listened to. Not only that, but they track us while we interact with the keyboard focusable elements, alerting us of bugs, and also, as I mentioned, allow us to analyze colors in real time, as well as contrast ratios, and raise bugs there as well. In the 3D world, though, there is no UIA tree, and it has no parallel. There is no semantic backbone for tools like Unity to create and set properties that automation devices can simply plug into. In 3D environments, we're creating with the assistance of light. But for augmented reality situations, we also deal with variable lighting conditions. Environmental conditions will always impact our experience of holograms and digital interfaces. Particularly when those holograms are text, we begin to very quickly run the risk of allowing an overexposure or underexposure. But the reality is that the variable nature of 3D environments is exactly where the opportunities for 3D devices lays. Humans are constrained by our senses. Seeing, hearing, touching. Indeed, each of us is locked into a very limited experience of a vast array of signals that are persistently available in our environments, but are imperceptible by us. Augmenting devices, by nature, give us the ability to perceive the unperceivable. The colorblind users who we mentioned moments ago might have conditions that reduce their sensitivity to the color red or the color green, which are actually simply wavelengths of light within the electromagnetic spectrum. Similarly, all humans are drastically limited because of our insensitivity to a wide range of the electromagnetic spectrum. But augmenting devices can assist us with this. Let's consider the example of sound. What we know about sound is that it's simply our brain's interpretation of vibration. We can already impact and adjust that to impact our users' hearing. The audio team at Facebook Reality Labs Research is just one of the teams that's working to refine two experiences that help users hear better in noisy environments using augmenting glasses and devices. We know that we can enhance spatial sound And we can also enhance that sound's acuity. What if you could turn up the volume on the person sitting across from you and simultaneously turn down the volume of unwanted background noises and individuals? How can we fine-tune a virtual sound with such high fidelity that it is completely indistinguishable from a real-world source? These are the questions that we've already asked and have begun to answer. Here's a video of a prototype where we use sound to increase the usability of the user's workflow and guides.
I'm jumping in real quick. What were we supposed to hear sound in this video? Because I don't think it's transmitting.
Oh, there's no sound. Oh, what a bummer is that. My system sound perhaps wasn't shared when I originally shared, and I'm just going to see whether it's possible if I can stop my share and restart it in case that was actually the issue.
Okay. Because I think with the other videos, but also people were asking, I thought like this is probably part of the presentation, but here you literally said sound, and that's why I'm jumping in.
Thank you for jumping in, and let's see if perhaps, and I don't see the opportunity to share sound specifically from my system.
Okay.
All right. Unless you have any recommendations on tech here, I think we'll have to move on.
Yeah, cool.
Thank you so much.
No problem.
And hopefully I am sharing here. I don't know if I hit the key. So essentially what we have there is a completely internationalized, in-context, spoken guide, where a user can both see a 3D hologram in real time, in real space, listen to the steps that need to be taken one by one, keep their hands in context and in place where the work is needed, and change steps one to the next, as you may have noticed, using their voice. This helps users with perfect vision. It helps audio learners. It helps individuals with text processing challenges like dyslexia. It helps people who have poor or impaired eyesight. But it is simply a more natural workflow. It's the way that most of us would learn from a mentor, talking over our shoulders or showing something to us in real time. And it becomes more natural precisely because of what it does not require us to do, which is leave the context of our work to attend to the needs of the technology. So in moving forward, we have to look for opportunities to unlock these workflows, not just for a small slice of our users, but for users across the ability spectrum. We all have an opportunity here in emerging technologies to let the device do the heavy lifting and let the user get on with their work. I do want to take a moment to invite all of you. There is, first I do want to thank everyone for your patience with the technical difficulties. And I also want to underscore a moment in time that we have entered that I'm very proud to be a part of at Microsoft, in that I have the ability to focus energy around enabling a wider and wider spectrum of users, and that Microsoft has begun now 10 years into its inaugural Ability Conference to open this process up to organizations around the world. It's decided to share its roadmap towards making technologies like what you're seeing more accessible to all. So I invite you at this point to check out some of the resources that are available out there for doing that. If your organization doesn't have a plan for approaching accessibility with its product, consider looking at those documents for inspiration. Thank you.